Hey guys, welcome back to my channel. So today I'll be starting with some of the basics of organic chemistry. Some of you might have some difficulties regarding the reaction mechanism. So I'm bringing the reaction mechanisms. So in this video, I will cover today SN1 and SN2 reaction. And in the upcoming video, I will cover the nucleophilic substitution reaction. So this is quite easy, so no need to worry, we'll enjoy it. So let's begin. So firstly, we'll now cover some of the basic terms which are involved, and then we will go to the actual mechanism. So some of the important terms are nucleophile, racemic mixtures, enantiomers. If you already know this term, you can skip to the next part, but if you don't, then so let's study together. So this nucleophile is basically a nucleus loving species. So nucleophile itself means nucleus loving or a positive charge loving species. So basically nucleus has a positive charge. So we are saying that nucleus attracting species, the species attracted towards the nucleus is called nucleophile. Now we will move towards racemic mixture. So racemic mixture is basically a equimolar mixture of two enantiomers. So you might now wonder what is an enantiomer. So enantiomer are two mirror image molecules. Okay, so now let us start with the next part. So there are two reaction mechanisms. First is the SN1 and second is the SN2. SN1 basically means substitution nucleophilic unimolecular, and SN2 means substitution nucleophilic bimolecular. So these are the full forms of SN1 and SN2. If we have understood this part, we have understood many of the things which will come ahead. Okay, so basically SN1 reaction is a two-step process, whereas SN2 reaction is basically a one-step process. So you might get a bit confused with why I am saying this as a two-step, even though I have written one over here. So when I'll explain you the actual mechanism of how this reaction happens, you will get an idea of it. So now let us basically jump to this point and then we will again come back to this point. Okay, so what happens is that in the case of SN1 mechanism, the leaving group departs first, meaning that if you have a CH3 Br type structure, so this leaving group, which is basically Br, will take its electrons and it will move out. So this step is a slow step. So we call it as the rate determining step. So here there will be a formation of a carbocation and the Br negative. So this is the first step in which the leaving group is departing. The second step is basically the attack of nucleophile. So this nucleophile, so once this bromine leaves the carbocation, you get a planar structure like this. This is called as the planar structure. So this planar structure, it can either be attacked by the nucleophile from the back side or it can be attacked from the front side. And then we will get two products which are possible. First product is CH3 nucleophile. Second product possible is that the nucleophile is attached on this side. So all the hydrogen, they will shift from here and they will get a bit of repelled by this nucleophile. So then how do we decide which one will be formed? So we say that both the products are formed, which is 50-50%, and this is called as a racemic mixture. So I told you earlier that racemic mixture is basically a mixture of equimolar enantiomers. So these are the two products formed in case of the SN1 mechanism. So have you observed something? That how do we write the rate of reaction for this process? The rate of the reaction will be, so here the rate of the reaction will be K times of concentration of CH3Br. This is because the reaction where the leaving group is leaving is the rate determining step. So you might have some like prior knowledge from the topic chemical kinetics, that when there is a rate determining step, so that step is a slow step, and when we write the rate of the reaction, it is K CH3Br from this. And since this is a elementary reaction, hence the power of CH3Br is basically the molecularity. So the power of the CH3Br is 1, hence the molecularity is 1. So therefore we say that it is substitution nucleophilic unimolecular, as the rate of reaction is this and the power of CH3Br is 1. Okay, so moving on to the next part where we have SN2 mechanism. So in SN2 mechanism, the full form is written as substitution nucleophilic bimolecular reaction, SN2. And this is a one-step process, meaning that in the earlier one we had a two-step process, like first the leaving group departs and then we have the attack of nucleophile. But in this case we will have a one-step process, meaning that the leaving group will leave and at the same time the nucleophile will attack. So this nucleophile will attack only from the back side. It has only one possibility, which is a bad side attack, because if it will attack the carbon from this side, it will face high repulsion due to this bromine. Hence we will only have the possibility of backside attack to this carbon. So therefore we will have a partial bond formed between this nucleophile and there will be a partial bond between bromine. So this is the intermediate, as I have written over here. So this is basically the intermediate, reaction intermediate. Then what we will get is nucleophile, and then there will again be a inversion of configuration. What I mean by inversion of configuration is, first we had something like this, and then we had a bromine attached to this side. But now after the reaction, all the hydrogen attached to the carbon have become reversed. So this is the initial state. Now this has become the final state. Hence this is called as the inversion of configuration. So this is also known as Walden inversion. So therefore we will have this product like this. So hence over here when we write the rate, so let me just clear this out, that this is the intermediate. This is not a first step then second step. It is a intermediate, meaning that this will be formed and then subsequently this will be formed, as this is more stable. So now when we write the rate of the reaction, we will write ROR equal to K CH3Br raised to power 1 and nucleophile, whatever it will be, raised to power 1. Meaning that in this reaction we have both the nucleophile and the CH3Br present in the reacting side. So like here we had only this step, which is the rate determining step, and we only had this leaving group process. We did not have this attack of nucleophile. So nucleophile was not present in case of SN1 mechanism, which is this one. So here we are seeing that we have CH3Br and the nucleophile both present. So hence this is a bimolecular reaction, whereas this was a unimolecular reaction. So now let us move on to the next slide. So now I'll be discussing the factors affecting each of the mechanism. So in case of SN1, we had the leaving group departing first, meaning that the bromine will leave first and then the nucleophile will attack. So this basically means that if there is a high electronegativity which is supplied by 3 carbons, that will be more preferable than having 1 carbon, as more electronegativity supplied by the carbon means more repulsion to this bromine and more easy departure of leaving group. So we can conclude from this point that the tertiary like carbocation will be more reactive than secondary than primary, because in case of the tertiary we will have the structure like this. So here the electronegativity will be provided by 3 carbons, and the bromine group will find it easy to leave, whereas in case of secondary you will only have 2 carbons which are supplying the electronegativity, so it will become a little less easy for the bromine to leave. I hope you got this point clear. So now moving on to the SN2 part. So SN2, the leaving group departs and the nucleophile attack happens subsequently. So we require less crowding on the carbon so nucleophile can easily attack. Meaning that less crowding means less steric hindrance. So that basically means that we need primary more stable than secondary, more stable than tertiary. So I hope you have got this point clear. Moving on to the next one. There are two kinds of solvents, polar protic and polar aprotic. So polar protic solvents, they give rise to H plus ions. So these H plus ions will favor in case of SN1, whereas the polar aprotic solvents which do not give H plus will favor HN2. So these are the two important criteria. First is the carbocation degree, and second is the type of solvent, whether it is a polar protic or polar aprotic. Okay, so in the Bal Bharati book we are given this table where we are given some important nucleophiles. So you have to memorize all these nucleophiles, as any of the nucleophile can be asked in the question. I have already provided a link to all these notes down in the description. You can check them out from there. So this is all for this video. I hope you would have got the concept of SN1 and SN2 delivered clearly. I tried my best, and if you did not get it, then try to go through the video again. I will share the notes down in the description box. You can check them out from there. Have a great day. Bye bye.